तो द्वारे द्वारे नदी नदी घूम रहे हैं कि ये बाबा उनके पाकिस्तान को दे लीक नदी जो गलत भी दे और भारत को मदद का रास्ता होते हैं बस जो मसले कर रहे हैं क्योंकि कोरोना संकटों में भारत दुनिया में सुरक्षा करा गया है वो भारत ने मारा जहाँ चौका कोई ग्राम को मिला मौका वही बहुत खुश हो रहे होंगे देखो कैसे तबाह हो रहा है हम उन्हें बहुत समझाए जब पाकिस्तान में टेस्ट होंगे ही नहीं तो वास्तविक स्थिति की जानकारी मिलेगी कैसे वैसे चीन से मांगे बगैर ईरान अपने मुल्क में टेस्ट तक नहीं करा सकते है वो छुट्टी लेकर निकल जाए और भारत में पहुंच सके ऐसा कैसे हो सकता भारतीय विदेश मंत्रालय के प्रवक्ता अनुराग श्रीवास्तव ने गजब का बोला ईरान और उनके पाकिस्तान पर दावा है पाकिस्तान को अपने लोगों को ऐसा नहीं बचा विदेश में बाहर गए आते हैं नकल स्थापना करने के लिए इमरान खान के कई सलाहकारों को और तो क्या है ना कि चोर को चोर कह दो और खुद को खुद उनसे बहुत वास्ता है ईरान की कसम खाकर रह गए होंगे क्योंकि उन्हें उनकी जीडीपी की याद दिलाई गई ठीक वैसे ही जैसे किसी को सिटी का दूध याद दिलाया जाता है सभी लोग पाकिस्तान की समस्या
So I'll be explaining about ultrasound artifacts. This slide showing the main beam. The main beam. This is the focal zone where beam is focused at this depth. This is the side lobe. This side lobe is produced due to vibration of crystal, which not only produce a sound beam in the main direction, but some beam is also produced along the side of the crystal node and side lobe. And the intensity of this ultrasound beam is very, very weak as compared to the main beam. And you have the grating lobe, side lobe, and grating lobe are same, except side lobe is produced due to single crystal or crystal element, whereas the grating lobe are produced by the electronic small piezoelectric crystals. Now coming to the ultrasound artifacts, there are certain assumptions which are made, and this is why artifacts are produced. One is that echoes detected originated from within the main. This is the main assumptions. So the first assumption is that echoes always detected from main ultrasound beam, but sometimes this is not the case because some of the ultrasound beam are detected outside the primary beam. Second is, and that is causing the artifact. Second is that echo returns to the transducer after a single reflection. This is what is the assumption, but sometimes the crystal makes multiple reflection and echoes are reduced. Echoes are detected. Third is that depth of an echo is directly related to the amount of time for an ultrasound pulse to return to the transducer as an echo. So this is the third because this measures the time, let us say 13 microseconds after transmission of pulse, and this is why it finds out the depth of an echo. Let's say if an echo is detected in 13 microseconds after transmission of pulse, then that echo will be assumed to have come from a depth of 1 centimeter. So this is how this depth is calculated. Fourth is that the speed of human sound is in soft tissue is constant, which is 1540 meters per second. However, if sound beam happens to pass through the fat, here the speed of sound is reduced, which is 1490 meters per second. So But sound beam assumes that the speed is 1540 meter per second. That it's causing the velocity error artifact. Fifth is sound beam and its echo always travel in the speed path, which is also not true because some of the echoes are detected from outside the mount beam and may be detected maybe in the seat. Sixth is the acoustic energy in ultrasound field is uniformly attenuated, and this attenuation is 1 decibel per megahertz per centimeter. So that is the attenuation is constant. So these 6 assumptions are there. We have to follow the assumptions. I mean, these are the assumptions through which ultrasound beam is generated, but these assumptions are not always uh, there, and therefore artifacts are produced. Common artifacts in the ultrasound is reverberation artifact, shadowing, acoustic enhancement, edge shadowing, beam width artifact, slice thickness artifact, slide globe artifact, mirror image artifact, double image or refraction artifact, equipment generated artifact, and refraction artifacts. So these artifacts are the main you can see. There are a few more. First of all, beam width artifact. You can see the beam is at this depth, the beam width is narrowed, and here the beam width is getting getting is more, and beam is traveling. This is the main beam. Now, if if an highly reflecting object is lying here, it will be detected by the sound beam. Or similarly, if uh, you can see in this particular case, this echo won't be detected by the sound beam. Whereas in this case, this is also being detected by the sound beam, and therefore this firing means bit artifact. So what I mean to say that there are certain the the slice thickness, it contains certain slice thickness. However, when it is getting the information, it is getting the information from the 2 dimensions. It assumes as if the slice is very thin. However, slice thickness has certain directions, certain depth, width, and if any echo is coming within this width, it is okay. However, if the sub echo is lying slightly beyond the beam, and they may be detected because of the highly reflecting object, and this is causing beam width artifact. You can see here, this is the beam width artifact. You can see in the gall whether it is lying certain structure. However, this is not the this is the artifactual image which is seen in the because of the beam width artifact. Some kind of uh, debris as if it is lying in the so main so how do we reduce these artifacts is to simply uh, image the patient in a different direction and we can find out. Second, we can reduce this kind of artifact. Second is the side lobe artifact. This side lobe artifact is produced due to ultrasound being generated uh, side to the main beam. See, this is the main beam which has the highest intensity, but because of the vibration of crystal, some secondary beam is also produced at the side of the crystal called side beam artifact. And these side beam artifact, because this beam is very weak, so ordinarily this is not going to cause much of the problem, but sometimes if this side beam happens to uh, pass through, this weaker signal happens to pass through a very strong attenuating structure, then this may be detected by the transducer containing side lobe artifacts. So this is because of the some side lobe artifact. You get the side lobe artifact or certain type of structure showing some debris in line in the. Then third is this reverberation artifact. This is very important kind of artifact. You can see this occurs basically when a highly reflecting object is lying near to the sound beam. So first of all, here this is the transducer, the surface of the transducer. First, ultrasound beam is going and interacting with the highly reflecting object and getting back reflected. So, okay, this will be this because let us say this is 13. This echo is this interface is uh, present at a depth of 1 centimeter. This echo is coming here and being detected in 13 microseconds. So this echo, this interface will be represented by this one. So this is the real image. However, if this echo is very highly reflecting object, then it might go and interact with the surface of the transducer. Some of the echo might be again back reflected and again interacts with the interface, getting back reflected. So this echo is coming back and forth again and again due to highly reflecting object and being detected. So this is called reverberation artifact. You can see here the first time is this. What would be difference? There are two uh, major difference. One is that this artifactual images will be produced at a depth of 1 centimeter from the real image. Number one. Number two point is that the intensity of echo every time getting weaker and weaker. So first image, artifactual image would be much weaker than the first one, but the second one is much weaker, third one is more weaker. So it is getting weaker and weaker as uh, because of the attenuation of sound waves. So this is showing the reverberation artifact. Uh, this is also, you see the reverberation artifact. This is the real image and this is the artifactual image, but this is equally spaced artifact is produced. You can see, and every time this is getting weaker and weaker and weaker. So this is called uh, reverberation artifact, which is very common in sound. Another type of artifact very related to the ring reverberation artifact, but this ring down artifact or comet tail artifact, this occurs only when highly reflecting objects like a needle or some uh, bullets they can because as the ultrasound beam interacts with the metallic structure, it getting it's like a bell keeps on ringing and producing the ultrasound beam. Uh, you know. So this is, you can see this is the ring down artifact or comma tail artifact. You can clearly see this kind of artifact. One more you can see this is the reverberation artifact and so that element, this is screws, driver, metal state, and producing uh, producing reverberation artifact. From the space reverberation artifact, you can say the ring down artifact. Very clearly, the ring down artifact are produced due to metal spectrum sun. Then this is called mirror image artifact. I would call it as mirror image artifact. So in mirror image artifact, if an object is lying here, you can see the ultrasound beam is getting interacting here and going here. Okay, so this is going to produce image. This is going to produce a real image, but some of the ultrasound beam is going through and interacting with the highly reflecting result. That's like a diaphragm, or you can see this is the diaphragm, and from diaphragm it is reflected uh, to the transducer, and here also this is going being reflected. So the so here also some of the ultrasound beam is reflected, some of the ultrasound beam is reflected here. So you can see here that because of the highly reflecting object, this is the highly reflecting object like the diaphragm. This diaphragm, uh, you can see the this is the artifactual image of this same object, because here it is highly reflecting object. It is going and reflecting here and coming back here, being detected by the sound beam once again. So this takes more time, and therefore sound beam assumes that this echo is coming from the deeper into the structure and causing a mirror image, because this is exactly produced opposite to this one, and this acts as a mirror. So like this occurs basically with the this is, you can see some pathologies, and this acts as a ribs, acts as a mirror. So produce the image of this one on the left side. On the of the hello, hello. Now this is, you can see, showing mirror image artifact. This is also showing the mirror image artifact very frequently. Now, second, next is the speed displacement artifact. I told you that when sound beam normally when it is passing through the soft tissue, the speed is 1,540 meters per second. Now, if some structure is lined, like the fat pathology is lined, and here there are some beam, if it is passing through this and the speed to the transducer, the echo will take more time. Echo will take longer time to reach of the transducer. However, transducer assumes as if this is coming from deeper into the structure. You can see that the structure is showing little bit deeper than actually is, and this is causing speed error artifact. So you can see there is some speed error artifact is occurring here. Then refraction artifact. Normally, when sound beam interacts with the structure, you can see it deviates from its original path. So it is coming here and going again and detected. Hello, 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 hello. So this is the refraction artifact. Now coming to edge enhancement artifact, we can say the acoustic shadowing artifact. If any stronger attenuated instruction is lying, so this will attenuate the sound beam completely, almost suddenly causing a shadow behind this strong artifact. This is called shadowing, acoustic shadowing artifact. You can see this is the showing the shadowing artifact, acoustic shadowing. Then as enhancement artifact. Here are acoustic enhancement artifact. Actually, an acoustic enhancement artifact, this is occurring in the structure, which is mainly like blood vessels or cyst, this kind of artifact. So under the cystic area or fluid filled structure area, you can see the area getting overcompensated. Why it happens? Because as the ultrasound beam passing through the soft tissue, it is okay. When ultrasound beam is passing through the uh, fluid structure, so you can see while it passing through the soft tissue, it is getting compensated. Compensation is 1 decibel per megahertz per centimeter. Suppose if an structure is available at a depth of 10 centimeter with a 1 megahertz transducer, it will get 10 decibel enhancement gain. However, if an structure, when a sound beam is passing through this structure, fluid filled structure, there is no attenuation. Virtually, there is no attenuation. And therefore, here there won't be any signal. But suddenly, just behind this structure, this area getting overcompensated because it is getting more compensation, and they should be comparatively hyper echoic as compared to fluid filled structure. So this gives you an indication of cyst or fluid filled structure, like uni bladder or any cyst or any fluid filled structure like gallbladder, etc. We will get this kind of hyperechoic structure. It is called acoustic enhancement. You can see this area is getting enhanced and just below the gallbladder. So with this, thank you for the sound artifact. So tomorrow there won't be any lecture, and I would be having test on 15th. So Saturday, Sunday, no lecture. We'll be having next lecture, next test on 15th. Then only I'll start other advanced techniques left out in the ultrasound CT. Thank you very much.